Hey, Dustin Vanoy here. I'm going to walk you through using KSQL, which is a SQL language for Kafka, to do some aggregations. And what we'll be doing is something that's actually not as easy as it sounds. We're going to do aggregations on data that's streaming from Kafka. So, in a streaming fashion, we're doing aggregations that will involve updates and deletes. So, this is something that I have not found a way to do with Spark yet. It's something that, if you have really good ways to do this that you like better than KSQL, please comment and let me know about those. But I found this to be the only way that I could easily do this without, a lot more code being written and without introducing my own data store. So what's going to happen is we'll use KSQL tables, which do involve keeping track of state. They do that with RocksDB, which is just embedded within the ksqlDB server. And so it's something that should scale relatively well, but you will need to think about how many unique IDs, how many unique keys you're going to have with your data set to make sure you don't end up trying to keep indefinite state on, billions of records. I'd say if you're doing millions, you're probably okay, but keep an eye on it. If you're doing billions, you're going to need to read up a little more and figure out if you have the right partitioning and things to make that happen. So let's dive into this use case I have and see how we do it with KSQL tables. In order to run commands for ksqlDB, we will connect to the Docker ksqlDB CLI container. So here's the command to connect to that Kafka container and run a KSQL client. As it spins up, it'll show us, what version of KSQL we're using and give us a prompt to get going. Notice that you can type help at any time to get some information, though really the online docs are probably a lot easier. We can start by just seeing if there's any KSQL streams. KSQL streams are pretty standard way of working with streaming data with Kafka, but you can do windowing and do things on top of them with KSQL, and it's really cool. But if you need to do updates and deletes, they just don't respect that Kafka key the way tables will. So why don't we just double check if we have any tables? Nope, no tables yet. We're starting from scratch pretty much. So the first thing we'll do is create a table. This could be on top of a Kafka topic that already exists, or you could have it create the Kafka topic for you. So from the broker, I can use the Kafka topics command to create a new topic. In this case, I'll just use replication factor 1 and partitions 1 because it's really just a throwaway topic for this demo. So now I can go create a table on top of that topic. Here's that command to create the table on top of the topic. I'm creating it called subscriber usage table. And in the with clause, I've specified the Kafka topic name and the value format of JSON. Note that since I'm using JSON, I do have to define the field names and the data types. If I was using Avro with the schema registry, I wouldn't need to define all those data types. I've also specified that the usage ID is the primary key. So this means it's actually the key in each of the Kafka records that's going to be used. And this allows me to deal with those updates and deletes smoothly. So let's go ahead and select some basic information from this table, and we'll see that there's really nothing there yet. Why don't I go and produce a little bit of data to this topic and you can see what happens. So we'll see some data start to flow in. I've got something like a 3-second delay between messages here. What we're looking at is usage data. Let's pretend we are working with data from Netflix and each video you watch is considered usage with its own ID. For that, we are tracking the user and the subscription type, which I'm calling plan here, and the event timestamp and the duration in seconds. So in this case, let's pretend we've got a couple of different variations of free plan and paid plan. I'm not really sure about Netflix, but in my demo, I do have that situation. And what can happen is a user can actually change subscriptions, change plans over time, and they can watch multiple videos in the same day, which you would expect. And we're trying to figure out how much usage do we have by day per user, but also broken out by subscription because we're going to need to determine, do we charge them for watching that video or not? And that is based on the type of plan they have. So in our data, we have 3 different users. User 2, you can see showing up twice with the same plan, free plan 1, and on the same date. And so now I'm going to do my daily aggregation. And what we'll see is an aggregate for user 1, user 2, and user 3. So here is my new table that I'm creating off of this aggregate query, which means that data will be flowing and aggregated in real time and available by calling out to the subscription usage daily table. Notice that there's a group by in here that is grouping by user, plan, and date. I'm using a substring to get the date out of the timestamp. And that's going to end up being the key for this table on the Kafka side. So to better illustrate what's going on, let's select all of the information that's in that table right now. And so what we have is you still see 4 records because it's keeping track of how it changed over time as the data comes in. But notice that the user 2 free plan 1 has incremented as the second message was received. So it went from a count of 1 to 2, and the total duration went from 30 to 45 seconds. Now, the important thing that led me to needing to use KSQL instead of Spark like I normally would for aggregations is I need to deal with, let's say a user should have been on a different plan. I need to subtract the one that's on this plan and add one to another plan. So let's see what happens when I change that usage ID 4, which is user 3, paid plan 1, to be a different paid plan. Okay, so we see that the entry we had went down to 0 and a new entry came in with paid plan 2. And so you can see that it's taken that update that we've sent. A little bit of more behind the scenes is here's what's going on in my underlying table. I sent one message, which is a correction to usage ID 4. And that impacted my aggregates. It shows the change so that anyone that's consuming this table can update their database with zeros for paid plan 1 user 3 and add an entry for paid plan 2 user 3. Now, maybe I realized that really none of this activity qualified and I need to delete this record. I need to delete usage ID 4. This will be a little bit harder to see, but we'll see the change come through on this aggregate query. So let me show you that. Here we go. I'm firing off a tombstone record, which means I'm telling Kafka to ignore the record that I'd sent before with this ID, basically consider it a delete. Now, depending on which tools you're using, the consumers need to be ready to deal with tombstones, to deal with these deletes. But in this case, the aggregations that we're creating and producing out there to Kafka will take it into account. And the consumer just needs to update their database to line up with what we're seeing as the latest record for this key. So there we have it. And by default, when I look at the raw table that I'm using, it does not show that tombstone here. But if I go, but it obviously knows about it because my aggregation changed. And if I go and use the console consumer to print out my topic, we'll see the very last record is how we do that tombstone. So I have my ID of 4, usage ID of 4 again, and my actual value is a null. So I sent a null payload to it instead of providing any JSON attributes. So with that, we have done an update, done a delete, and considered all of those in our aggregations within KSQL. Note that we could send with different days, send with different users, and it'll keep each of those calculated based on the group by clause. So there's quite a bit we can do here, but we do want to keep in mind how many unique keys we'll have for each Kafka table that we set up with KSQL. I hope you found that valuable. I hope that helps you get started doing aggregations with KSQL. See you next time.